Good evening, ladies and gentlemen. Welcome this evening. My name is Greg Naderer. I'm the Dean of the Faculty of Engineering and Applied Science, and it's a pleasure to welcome you here this evening to our Speaking of Engineering lecture series. I'd like to extend special greetings this evening to our guest speaker, to my right, who is Dr. Steve Butt. Dr. Butt is a professor of process engineering here at Memorial University. Welcome, Steve. I'd also like to acknowledge this evening to my left, Jeff Emberley, who is the Chief Executive Officer and Registrar of PEGNL, that's Professional Engineers and Geoscientists of Newfoundland and Labrador. Jeff will come up to speak a little later on PEGNL's sponsorship of this lecture series. So this session is co-sponsored with PEGNL. And as many of you will know, PEGNL is a provincial organization with the mandate of regulating the profession of engineering and geoscience in the public interest. It has over 4,000 members in the province and beyond, and we're grateful to PEGNL for their support. Just a few housekeeping items before we begin. In the event of an alarm, let's exit this room calmly, and we turn to the right as we exit and go through the main exit doors of this foyer. And then we pull another left, and the muster station 22 is across the street in the business parking lot. Also, in terms of washrooms, you can go to those if you go immediately to your left as you exit the room. So this lecture series raises awareness of engineering issues among students and the community. We're very proud of the work that we're doing here in the faculty. The research that is being done by professors and the activities by students are second to none. And I'd just like to spend a few minutes telling you about some of these recent successes. So just a little bit of shameless self-promotion before. We're very proud of our students who raised $23,000 a few weeks ago in support of a local charity, the Special Olympics of Newfoundland and Labrador. They hosted the 13th annual charity ball event, and the proceeds from that went to this charity. It's an annual event that our students do, and we're very impressed and pleased with their how they are giving back to the community. We also had some great student successes a couple of weeks ago in the Atlantic Engineering Student Competition. 17 of our students attended, and 13 of those placed either first or second in the competition. In fact, 2 of our teams placed first, one in the communications category and another team in the consulting category. They're going to go on now to the National Engineering Competition in Waterloo next month, and we wish them all the best. Our students are also giving back to the community beyond that charity ball in volunteering activities. And in fact, again, a few weeks ago, Lieutenant Governor Judy Foote presented volunteer program platinum awards to 4 of our graduate students for the outstanding volunteer work that they're doing in the communities. So Tobias Bruckner, Murtada Al-Hajj, Mohammed Mia, and Mohammed Odan, 4 students that are really giving back. And I'll just end up with one more. Many of you will know that our alumni also have tremendous success. In fact, a couple of alumni had recent executive appointments in the province of note. Jennifer Williams, a graduate of our civil engineering program from 1998, was appointed as the first female president of Newfoundland Hydro very recently. We're very proud of that. And also Jim Haynes, 1977 electrical grad, was appointed as executive vice president of Nalcor Energy Power Supplies. So we are very proud of the success of our alumni. Anyway, getting back to tonight's lecture. Tonight's lecture will give a history of mining in Newfoundland and Labrador, starting in the mid-1800s. Dr. Butt will look at key discoveries that have happened in the province, the demands during the war periods, 20th century industrialization, mechanization in the mining industry, and the future direction of mining in the province in terms of technology, industry, and environment sustainability. Dr. Budd has been a faculty member here at Memorial for over 20 years. He's a world-leading expert in drilling, mining, and the development of natural resources in terms of his teaching, research, and many collaborations with industry. He was a faculty member at Dalhousie University prior to Memorial. He holds several patents and technology licenses. He's also developed a world-leading advanced drilling lab, which, by the way, you're welcome to come and visit anytime. He's held several administrative leadership contributions. He's served with the Canadian Engineering Accreditation Board, the board of Newfoundland Labrador Angels Network, among several others. And in fact, Steve is competing this weekend in Toronto at Goldcorp's Disrupt Mining Challenge. This is a global challenge that has selected 3 finalists, of which Steve's team is one, to present to a panel a leading technology in mining. And so Steve has worked with Anaconda Mining. They've developed a sustainable mining by drilling technology that is unlike any others that can unlock gold deposits in narrow, hard-to-access areas. So he's competing in the weekend in Toronto. We wish him all the best and thank him for coming this evening. So let's give Steve a round of applause as he starts this evening.
Thank you, Tom. I'll turn it on first. Thank you, Dr. Natter, for the introduction. So as it was introduced, this is about mining in Newfoundland and Labrador, past, present, and future. It is, in fact, a very detailed and long topic, so you're really getting the Cole's Notes version of this. All right. Just a snapshot. In 2018, what is the mining industry in Newfoundland and Labrador? As indicated there on the screen, there was a gross value of mineral shipments of around 3 billion Canadian, 4,791 person years of employment. So that's one person employed for 4,791 years, or 4,791 people employed for 1 year. So that puts it in perspective. We had 11 producing mines, 4 developing properties that are coming into production. In terms of GDP, they represent about 6% of the GDP of Newfoundland and Labrador, but that's a little deflated. If you look at recent mega projects, smelter developments, things like that, that would actually make that a little bit higher. And unlike some industries, the employment is spread throughout Newfoundland and Labrador, touching all parts of the island and many parts of Labrador. So how did we get here, and where are we going in terms of mining? This is the agenda I had scheduled for this evening. I want to give some background and geological context, because we're going to talk about some issues dealing with mining, geology, and so on. That includes a bit of a mining overview, mine types, and some terminology. I'll talk very briefly about historical mining, which is before the major industrial period. But most of this talk is going to be on Section D, the modern mining period. And again, because of the timeline involved, I'm going to focus really just on major mining operations or long-term activities. The list of them is given there, and I'll go through those during the talk. And finally, ending off with mining innovations in future. Where we are with mining today, how that differs from mining even just a generation ago, and where are the trends leading into the future. This is a map, actually. It's a geological map of Newfoundland and Labrador. I'll just turn around here. Just like all other parts of the world, our province is composed of different types of geological zones. Sometimes they're called terrain, sometimes they're called provinces, but ultimately a zone is a region that has similar geology, a similar age, and a similar deformation history. And because of that, you end up getting very similar types of mineral deposits, economic mineral deposits in each zone. And you can also predict somewhat the type of, you can predict the type of mineral deposits that will be present in the different types of zones. So you see there's 3 major zones here on the island of Newfoundland. and about 5 or so for Labrador. Just let me step over here. These are the types of there's actually 3 major types of sort of zones. One is igneous terrain, where you've got a lot of volcanic rocks, rocks that have crystallized from molten rock. Metamorphic zones are those that are have been altered. So there's been some processes involved. There's been rocks that have been deformed, recrystallized. There's been fluids flowing through, depositing minerals, and so on. We often put igneous and metamorphic together as hard rock because they've had some deformation and certain characteristic type of deposits that occur there. The third type is sedimentary zones, and sedimentary zones, of course, are more well known for oil and gas, but that's where you have energy resources, coal, oil, and gas. You have evaporites, which are gypsum, potash, and salt, limestone and shale, which are used for cement production and other industrial processes. And there is one type of metal deposit, the carbonate-hosted lead zinc, which does occur in sedimentary terrains. Of all the zones here in Newfoundland and Labrador, the western zone is sedimentary zone. All the others are igneous or metamorphic. And again, because of the time frame involved, I'm really going to exclude dimension stone and aggregate. Basically, anywhere in any zone where you can get very strong, competent rock, you can produce dimension stone for construction purposes, or anywhere where you have strong, competent rock, you can crush it up to make aggregates. So really, we're not going to focus on that here this evening. There are 2 basic mining methods that are used both here, of course, and most places in the world, and those are surface and underground mines. Surface mine is shown here. Again, there are several types of surface mines. The most common one that would be in use here in Newfoundland and Labrador is what's called an open pit mine. An open pit mine is used for a shallow, near surface, near horizontal deposits. And this is a photograph of an open pit mine here. This is a sketch through a typical type of an open pit mine. The green is the ore body that is removed by the mining process. And this is just a computer-generated image used for mine planning for this particular pit over here. One of the characteristics of 2 of the major characteristics, I would think, of surface mining is that it does have a fairly large environmental footprint. There's a large excavation. And in terms of waste materials, there's 2 types of waste materials that are generated by this type of mining. The first is what's called waste rock, and that's just basically non-ore. So if you look at this sketch up here, all this region that was excavated, this would have been waste rock. So that's not ore, that's not processed, that's set aside usually into a waste dump or storage. But when you recover the ore and you process the ore, you're concentrating the minerals that are in the ore, and the leftover parts of that concentration are the tailings. That's the low-grade or barren minerals that are present in the ore. Those are usually sand-sized. So at the end of the day, you end up with 2 major waste products. Waste rock, which is coarse, inch size up to basketball size, and tailings, which is sand size or smaller. And for a surface mine, these are generally stored at or near the surface operation. This is waste rock stored here at the mine, and a tailings pond would be is a place for the storage of the tailings. Because it's usually an aqueous process or a water process, usually tailings are hydraulically transported, and you end up having to drain some of the water from the tailings. As well, many surface mines will also have what's called an economic pit limit, below which it's no longer economical to continue mining. And for many deposits, portions of the ore body will extend below the economic pit limit. The other major type of mining operation is underground mining, and there's a lot of variations on underground mining depending on the nature of the ore body, the geometry, the strength of the rock, and so on. But a very typical example is shown here. And what are some of the main characteristics? Well, it's usually for deeper, obviously. there may not be any exposure of the ore body at surface at all, so you have to go underground to access that. Or steeply dipping deposits. And steeply dipping deposits, which is one shown here, if you had to excavate a stable open pit mine for this one, you'd have to have a very large pit, which would have a significant amount of waste to ore in that pit. That's what's called the stripping ratio. And at some point, that stripping ratio is uneconomic. So underground mining is better for this type of a deposit. Generally, if you look at this, the development is what's called the footwall of the ore body, and generally less waste rock is generated because you're only excavating openings in that host rock. And as well, both the waste rock and the mill tailings can be incorporated into backfill to the openings underground. So what that ends up giving you is generally a smaller footprint at surface, both in terms of the disturbed area and a smaller storage requirement for tailings and waste material. However, underground mining generally has a higher cost per ton compared to surface mining, so it is a more expensive form of mining. As is shown here, the developments access the ore body in very regular vertical intervals. Those are typically called levels, and then the ore is excavated in the intervals between the levels. This particular one here is shown as actually a non-mechanized operation, but many underground operations would be, in fact, highly mechanized, and it would be a lot of mechanized equipment doing the drilling, doing the excavation of the blasted fragments, installing ground support, and so on. All right, so that was Mining 101 in about 10 minutes, so here you go. Historical mining. Again, I've broken this up into a historical period, being largely before about 1850. And the first part I've called colonial mining, or pre-colonial mining, really is only known by archaeology. So we don't have any records for that. But I've just given some examples there. 7,000 years ago, there was mining of chert as a stone material by indigenous inhabitants in the area. And this material is called Rama Bay chert, and it's shown up. It must have been traded because it's shown up in all kinds of different archaeological sites as far south as the United States. Two here, there's evidence of about 6,000 years ago of Aboriginal people excavating soapstone. There's a soapstone quarry there. Three, there's archaeological evidence of the Vikings in 1000 AD excavating bog iron, which they used to make iron for boat making and things like that. And of all the pre-colonial period, there is just a single mine that was operated by colonial people, and that was the Skully Mine. It's just south of here on the southern shore, and it was operated just for a single year in 1776. It was a copper mine. And I think if you walk along the East Coast Trail, you can see evidence of where that mine was located. And an interesting note, the three developers of the Skully Bay Mine were granted a mineral concession by the King of England at the time for all the minerals in Newfoundland and Labrador for 999 years. So it's a good thing to actually let that concession lapse, because otherwise there'd be nothing left for anybody else. All right, there you go. 999, I didn't say it there, 999 years for all the minerals in all of Newfoundland and all of Labrador. Okay, good thing that they weren't very good at mining. All right, so the modern mining period. That really started around the mid-1800s, and there were several things that contributed to this modern mining. First was an organized, organized professional mineral exploration. There was a geologist hired to do an initial geological survey of Newfoundland, the island of Newfoundland, in that should read 1839 to 40. That's a typo. J.B. Jukes, and he did a sort of a preliminary survey. About 20 years later, a formal geological survey of Newfoundland was opened in 1864, and those were professional geologists, professional mining engineers who would go around and explore and map, specifically looking for mineral deposits. And one of the very first mineral deposits of the modern era was discovered at about that time at number 1 here, Tilt Cove in Notre Dame Bay. There was a discovery of copper ore. I think it was copper, lead, zinc, but copper was the primary mineral in 1857. The deposit was explored further, and a mine was developed at Tilt Cove. It started in operation in 1864, and it ran for almost 50 years to 1913. So that was a 50-year operation. And in fact, at that time, copper was a mineral that was high in demand because at that time there was a growing electricity industry in the world, and copper was needed for wire. So in fact, that discovery led to a major boom in copper mining in the Notre Dame Bay area. And again, because it's all in the same zone, similar geology, there were many similar type deposits in that area. There were several long-term mines, as indicated there on the slide, Little Bay, Betts Cove, and Pilley's Island mines, which operated for several decades each, and several others that were smaller and short scale. And just to put it in perspective, this is a close-up of all the mines that operated in Notre Dame Bay during that period. If you count the number, there's 30 mines there. So there was a significant amount of copper production in Notre Dame Bay during that 50-year period. And in fact, Newfoundland at that time was the world's 6th largest producer of copper. So that was a significant period of mineral production in the island. And also at this time, because again, these deposits were mined for significant periods, this is the first time that there were actually mining towns, sustained mining towns that developed in the province. And Tilt Cove, Betts Cove, Pilley's Island, and Little Bay were 4 of those mining towns. That ended actually in 1913. There was a crash in copper prices worldwide, and also the advent of World War I and metal shortages and so on basically ended the copper boom. But it had a good 50-year run. Belle Island. Many people, of course, are familiar with Belle Island. It's the island of Wabana, just in Conception Bay there, just off of Portugal Cove. Iron deposits had been known there since about the 1700s, but they were not really fully understood. The geologist that was hired, in fact, in 1839 to 1840 to do a geological survey, he might not have been all that good, actually, because he actually saw the rocks. He just noted them as bright red rocks and didn't actually recognize that they were iron ore, so he missed out on that. But in the 1880s, a fisherman from Port de Grave, he had used these rocks because it's iron ore, so it's very dense and heavy, and he was using that as ballast in his boats. And one of his sons recognized the potential, and he had the rocks assayed, and they contained a very, very high grade of iron. So he and his sons actually got the mineral rights for the deposit, and they later went on to be some of the earlier pioneers for mining in Newfoundland and Labrador. The Butlers and their partners, I think at the end of the day it was their partners who first developed the mine. They started mining in 1894. And the initial deposits were at surface. So they had some fairly basic surface mines to excavate the iron ore that was available at surface. But then when that was depleted, they moved underground. And they moved underground basically out under Conception Bay. So they had submarine mines that were excavated out onto the bay. And of course, a lot of you have probably seen photographs like this. Up until very late in the operation of the mine, they used horses underground. And the horses basically were used to pull the ore carts. And many of these horses didn't come above ground at all during their life because they would have been blinded by the bright lights. All right, just some of the history. It operated almost continuously from 1894 to 1996, so that's almost 70 years. So that's one of the longest running mining operations in the province. It operated under various different consortiums and companies and that, but at its peak, about 90% of the economy of Belle Isle, in fact, was based on the iron mines. And most of the iron that came out of the iron mines in Belle Isle was associated with steel production in Sydney, Nova Scotia. So that ore was shipped over to Sydney, Nova Scotia. And in fact, it was also associated with a limestone quarry, number 2 here. Again, this is the sedimentary western zone of Newfoundland. And a limestone quarry here at Agathuna was also operated for a significant period of time, about 50 years. And that limestone, combined with the iron ore, was used in the production of steel in Nova Scotia. During the 1930s, with the reduction of industrial activity, there was a decline in demand for iron. But surprisingly, the mines had a new buyer. It turned out to be Nazi Germany, because Germany at the time was rearming, and it's ironic that a lot of the iron that was used for that actually came here from Belle Isle. And also, during the war, just a few years later, several ore carriers were sunk by U-boats while they were at the docks at Belle Isle. Ultimately, the mine did close in 1966. It had several things. The iron mines in Labrador were coming on stream, which could produce iron for less. But ultimately, it was also related to a change in the metallurgical process for steel making, and the content of that ore was less valuable. So, but still, it operated for about 70 years. The next, and I'm going a little bit in chronological order. The next major mining operation was in Buckins, and that's indicated 1 here in central Newfoundland. That was actually first discovered by the A&D company, the Anglo-Newfoundland Development Company, which had concessions for timber, pulp and paper, and minerals in central Newfoundland. And in fact, they did so they explored for many things, but ultimately there was a discovery of a copper-lead zinc deposit at the location there at Buckins in about 1905 by prospector Matty Mitchell. So it was assessed to be a sizable deposit, and fairly quickly a mine was developed. The Buckins River mine started in 1907, but it closed actually just 4 years later, and part of that was that the ore that it produced, copper-lead-zinc combination, was not very compatible with the smelting and processing processes that were active for the day. So it ultimately closed in 1907. And in fact, the A&D company went on later to form pulp and paper mills at Grand Falls, and they operated those for over 100 years. However, there was a company based in the United States first started showing interest in the Buckins deposits around 1915. It was the Asarco, the American Smelting and Refining Company. And they were largely a refining company, a smelting company. And they had developed a process, a smelting process, which was far more compatible with the type of ore that was present. The copper-lead-zinc ore, it's called a VMS-type deposit. The copper-lead-zinc ore that was present in Buckins. And so they did some testing on the ore, did some test excavation and so on. And their smelting process turned out to be quite successful and compatible with Buckins. So they ended up securing the mineral rights. And they started a new mine development, which went into production in 1926 with the deposits that had been previously discovered. This was also one of the first times that geophysical technology was used to help explore the subsurface. And they had some very successful results there. And within a relatively short time, they delineated 6.6 million tons of ore, which is just a significant amount for the rate of mining that was done at the time. The mine as well also developed hydroelectric power at Deer Lake, which is still in operation today, and that was to operate the mine and the mill plant at Buckins. And again, just for each one, rather than have just sort of dry data, I have a picture. And so for this one, I have this is the head frame for one of the longest running mines at the Buckins site, and they were in operation from 1928 to 1984. So again, over 50 years. During the course of their history, they did have some problems. They had roof falls that today we'd call those rock bursts, and they're related to the way in which you mine and you stress the rock. And they had problems with rock falls. And in fact, my grandfather, James Penny, was one of the miners who was injured in a mining accident in 1950s. And he was off work for about a year while he was recovering. Anyway, he went on to go back mining, and he passed away about 10 years ago. They also had a series of strikes, actually, in the 1970s, and I was surprised to find when I was doing the investigation for this, a professor here, Howard Dyer, he's no longer here now, but he was a professor that I had when I was a student here several years ago, 30 years ago. And he actually led a commission, the Dyer Commission, which looked at solving some of the labor problems that they had at the Buckins Mine. And ultimately, the mine did close final production in 1984, and mostly because they just mined out all the ore that had been delineated. All right. The next one chronologically would be St. Lawrence Fluorspar. St. Lawrence is located down here on the toe of the heel of the Burin Peninsula. Fluorspar is used as a flux in smelting. There was evidence actually that there had been some mining for lead in the fluorspar zones pre-1825. I don't think they ever did discover who actually had done that, but the actual fluorspar veins themselves were discovered in 1925. Two independent companies developed operating mines for the numerous fluorspar veins that were delineated, starting in about 1933. During World War II, the mining operations scaled back largely due to wartime shortages of mining equipment. And in fact, one of the companies did go bankrupt in the 1950s, and it stopped production in 1957. But it was actually acquired, and both companies and both sets of mines were operated by Alcan, the big Canadian aluminum producer, who did use the fluorspar produced there for their aluminum smelting process. But it did close in 1978 when Alcan had switched to another source for fluorspar. Mining was briefly restarted in the 1980s, and was actually restarted again in 2017 by a current mining operator, Canada Fluorspar. Many of you who are maybe familiar with St. Lawrence mines are familiar with the industrial diseases that they had there. In the mid-1940s, many of the St. Lawrence miners were diagnosed with what they thought at the time was tuberculosis, and they were treated for tuberculosis. They came to the sanatorium in St. John's. They had whatever the treatment they had. They went back, but a lot of them still died. So it took a while. It was about it wasn't until 1957, or it wasn't until about the 1950s they discovered that many of these people were dying from lung cancer. And in 1959, it was definitively determined that there was radon gas entering the mines because of the mining process, and there was minerals in the fluorspar veins and in the hosting granites and so on that produced the radon. So very quickly, when it was discovered, the mine ventilation systems of the time were improved. The mine ventilation system moves fresh air through the mine clears the blast gases and so on. And the mine ventilation system was determined to be inadequate before this time. That's what allowed the radon to build up. And this is a photograph of miners doing air quality testing in 1960. So once that problem was recognized, the ventilation systems were upgraded, monitoring was implemented and so on, and really it didn't become a problem after that. But it was estimated that as a legacy, about 200 to 300 of the miners who did work there ultimately died from radon exposure. I want to put this up here. This is a collection of mines and deposits. Coal, gypsum, cement, asbestos, talc, and so on. These would be somewhat what we would call industrial minerals because they can be excavated and there's not much processing involved. They can be crushed, sorted, maybe some separation, but they can be largely used as they come out of the ground. And so this is an example of these were the major industrial minerals that were produced during the 20th century and on into this century here. I put down coal first. Many of you may be surprised to know that there are in fact coal deposits here, and they did operate for a period of time on the shores of Grand Lake here at number 1. It was actually part of the mineral concessions that the Newfoundland Railway Company had when they developed the railway across the province. They were given large mineral concessions on either side of the railway. They actually have what were called fee simple concessions, and fee simple include everything: water, minerals, timber, and so on. And they did discover coal deposits here at Grand Lake, and they did operate coal mines there sporadically from about 1898 to 1920. But to my knowledge, there hasn't been any further coal production there. Gypsum, here at number 2 here at Flat Bay at St. George's Bay there on the Port Hope Peninsula. There was a Flat Bay mine operated there from 1951 to 1994. So again, 43 years of production by several operators. And in fact, 2 operating mines have just opened in 2017, excavating gypsum at that site. Red Moon Resources and Galen Gypsum. Cement. Here at number 3, that's basically Corner Brook. And I call it cement, but really, as I indicated before, 2 of the main ingredients in cement are limestone and shale. So there were separate limestone and shale quarries operated in the Corner Brook area. And again, that was a long-standing operation that ran from 1952 to the year 2000, so almost 50 years of operation. Asbestos here, number 4. Asbestos. Advocate Asbestos operated from 1963 to 1991, producing chrysotile asbestos in the Bayverde area. And I put down here talc. Talc, or sometimes called pyrophyllite, there's actually a very long-standing talc mine that's been in operation in the Manuals area here in Conception Bay since 1957. And it's been currently operated now by the most recent operator is Trinity Resources, and that talc is used in the production of porcelain. And all these operations, all of them, were surface mines, so they would have been variations on the open pit mine that I showed earlier. I put down here 20th century base metals. If you look at this list, there's a whole pile of base metal mines, and if you look at the dates, most of them were short-lived. The longest one there on the list, I think, is probably about 15 years. Most of them operated for less. I put them all just on a single slide just to be comprehensive. Right? Tilt Cove, Little Bay, and Whalesback, and Gull Pond, or the Gullbridge Mine. 4 of those mines were actually some of these copper mines that operated in the Notre Dame Bay area during the copper boom in the late 1800s. They were actually reactivated for short periods of time, 10 years or less generally, to produce copper again. Rambler, number 3 here, again on the Bayverde Peninsula, was a new deposit, copper, lead, zinc, It operated from 1964 to 1982, and then it reopened, in fact, in 2012, and is still in operation after the discovery of new zones. In fact, the new zone, they found that it was about 500 feet away from the old zone, so they didn't do the good exploration in the beginning, but it was fortunate that they did actually find the further resources. And they've done a lot of delineation there. They've got a further 20-year mine life left for that deposit. Daniels Harbor, up here on the, going up on Northern Peninsula, a zinc mine operated there from 1975 to 1990. And I said 20th century, but you notice several of these aren't in the 20th, they're actually in the 21st century. The Duck Pond mine here in the Millertown, Buckins area, operated copper lead zinc operation there from 2007 to 2015, so about 8 years. And Beaverbrook antimony mine here over near Glenwood has been mining antimony sporadically since about 1997 under several different operators. All right, everything I've shown so far is Newfoundland, because again, we're going in chronological order. There wasn't a lot of exploration in Labrador in the beginning because of where it was located, and mineral rights and political boundaries weren't really defined until well into the 20th century. The first, and this is really focusing on the iron mines of Labrador West, the first concession for mining and exploration was issued actually in 1936 and led to the discovery of extensive iron deposits at Shefferville. At the time it was called Knob Lake, but since then it's been renamed Shefferville, here labeled number 1 on the map. And it was operated actually by the Iron Ore Company of Canada from 1954 to 1983, so again almost 30 years. That activity led to discovery of much larger deposits, number 2 at Carroll Lake, where it is now Labrador City, and IOC has operated the Carroll Lake mines and a pellet plant at that location since 1962. And they have a very extensive resource. Whenever you see their resource table, they just say 99 years, because I think that the table can't take 3 digits. And in fact, that's a shot there. This is a recent shot showing 2 of the active mines at the IOC site near Labrador City. The Loose mine, which went into operation about in the 1990s, and the more recent Wabush 3 pit, which is much more recent. And they have lots of ore in that area. The Skully Mine near Wabush, which is actually not far away, close to Labrador City, was operated from 1965 to 2014. And it's actually being reactivated now by a new company, Takora Resources. So it was closed and shuttered 2014, 2015, but Takora now is doing the advanced exploration and feasibility studies to potentially bring that into production again. And in fact, there's a new company has gone back into the Shefferville area, the Knob Lake area. Tata Steel from India is partnered with New Millennium Iron, a Newfoundland based company, and they operate about 11 mines near Menahek here. They've been operating since about 2012. And they've got a posted resource life of about 20 years. And there's several other companies. I haven't put them up here for the sake of brevity, but there's several other companies that are active in that area with advanced exploration. Some are almost nearing production and so on. And these are major operations. I've indicated, the Carroll Lake operations that give a resource life of 99 years. Essentially, it's very extensive. And there's about 2,000 people who are employed full-time, operating, working in these iron mine operations. All right, the next big major activity in Labrador was Voiseys Bay. Voiseys Bay mining and smelting operations have been active. I say Labrador, but of course smelting is active here now on the island of Newfoundland. But they've been active for mining and smelting production since 2005. The original Voiseys Bay nickel, copper, cobalt deposit, shown one here, which is just to the southwest of Nain, was discovered in 1994 by a company who was actually looking for diamonds. I think you recall diamond fields. I forget their name now, but anyway, they were looking for diamonds, and the discovery of a major base metal deposit was not their target. But to their credit, they did stake it and so on, and it led to a very active exploration program. And I think for a time there, I think 10% of the people who lived in Labrador were at some point involved with the exploration for this deposit. In 1996, it was acquired by Inco, which of course later Valley. And surface mine operations began in the what's called the near surface ovoid zone around 2005, and current mining development is active to access several deeper zones, the Reed Brook and Eastern Deep zones, with first production expected in, I think, 2021. There you go. That's right. The person in charge of that development is sitting in the front row here, so he's going to give me a critique later. In fact, I do have some geology information to help with that as well. This is a section. It's about 3 kilometers, so 3,000 meters through the zone. This is where the current open pit, the near-surface ovoid zone, is present, and these are ramp and decline accesses that will access the eastern deeps to the east of the ovoid zone and the one to the west. And those, again, are active, and production is expected in just 2 years. I'll also mention, of course, smelting. They completed Valley completed a new Highgerman nickel smelter, capacity of about 50,000 tons of nickel per year at Long Harbour, Placentia Bay. That was one of the recent mega projects I talked about in terms of contribution to the provincial economy. And again, operations started in 2014. That Highgerman smelter takes ore, of course, from Voiseys Bay, and that's delivered using ice class ore carriers that carry it from Nain down to the island at Long Harbour. But that's a long-term facility that will also take ore from other nickel mining operations worldwide. Precious metals. I've left this one for the end. Precious metals are basically gold, silver, platinum, palladium. Just differentiate them from base metals. For much of the mining history of Newfoundland and Labrador, gold and silver in particular were present as accessory minerals in these base metal deposits. Whenever you had copper, lead, zinc, copper, lead or zinc, there was often some gold and possibly some silver mixed in with that. So that was a source of much of the precious metal production. But development of just gold-bearing quartz veins all by itself never really started. Hasn't been as big of an operation. There were 2 discoveries indicated here, Ming's Bight and Sop's Arm there on the Green Bay and in White Bay. These were actually delayed by French shore restrictions. Just to give a little history, this part of Newfoundland, the part that's actually mostly shown here by the western zone and the southern coast up to about Fortune Bay there, was called the French shore. And that was actually patrolled by the French Navy, who controlled access to that area until about 1904. So at the time these deposits were discovered in the 1880s, they couldn't develop them because they had problems with dealing with France. And that was only resolved in 1904, in fact, when Britain exchanged the west coast of Newfoundland four, four colonies, Nigeria and Ghana in West Africa. Eventually, though, the political issues were resolved, and these mines did go into production, but they were very short-lived. The Goldenville mine, which was the one discovered near Ming's Bight, only operated for about 3 years, 1903 to 1906, and the Sopsar mine just operated for a single year in 1903. There was actually, during this time, another mine, Silvercliff, which was operated at, well, at the time was called Little Placentia, now it's called Argentia, in Placentia Bay. And it operated for a 3 or 4 year period in the 1880s, and again for 3 or 4 years in the 1920s. But again, not that many precious metal mines, relatively short-lived. That changed a bit during the 1980s. For those of you familiar with mineral exploration in Canada, from 1983 to 1991, 1983 to 1991 was a period called flow-through shares, and there was a tax incentive to explore. So there was a lot of exploration done that wouldn't normally have been done because of the tax incentive. And that led to, across the country actually, a lot of discovery of relatively smaller deposits which probably wouldn't have been found before then. Also some big deposits were found, but it also, because of the activity, a lot of smaller deposits were found as well. So shortly after this period, and during and after this flow-through shears period, a lot of standalone gold deposits and gold mines were operated. One of the most well-known was Hope Brook here on the south coast of Newfoundland, operated from 1997 to 2001. Hammerdown Gold, or the Hammerdown Gold Mine here on the Bay Peninsula, operated for 3 years, 2001 to 2004. And before that, the Nugget Pond one here, number 2, operated from 1997 to 2001. And I put down one of the most active operators down there, number 4, Anaconda Mining, because Dr. Natter pointed out, that's a company that we are doing a lot of collaboration with here at Memorial. So I just want to point out what their operations are. They operate basically a Point Roos project, which is a number of these smaller deposits in several open pits in that area. Pine Cove Mine, which operated for about 10 years, and the Staggertite Mine, which just started operation about a year ago. And that's actually a photograph there of some of their mining operations. They're both surface mines, Pine Cove and Staggertite. And that's a photograph from the Pine Cove Mine, which just closed earlier this year. All right, so that's a Coles Notes version of the history of mining in Newfoundland and Labrador, taking us right up to today. Current mining practices. Even just a generation ago, you'll see some significant differences between mining as it happens today in the province and really across the country compared to the way things were done. One of the things that's very significant and prominent is a focus on occupational health and safety. Safety, of course, is paramount, and that's in part to be consistent with occupational health and safety regulations, which are fairly strict and structured, and there's been fundamentally a change in culture in the mining industry focused towards safety. There's mandatory training, certifications, workshops are required, PPE, hearing protection, dust protection, air quality monitoring. There's a lot of occupational health and safety things we take for granted today, which a generation ago weren't in common practice. Another thing that's relatively new is the concept of a fly-in camp. In days gone by, a mine would be developed and a town site would develop there. And when the mine closed, you'd be left with the problem of having a town, a ghost town, and there'd be problems with people selling their homes and things like that. So what's happened more recently now is that for remote areas, you're likely to have what's called a fly-in camp. So you no longer have a town site. You basically, personnel are transported in from several key locations. You may have several crews. You may have a crew A and a crew B, which rotate in operations. But at the end of the day, it avoids the issues with a single industry town closure when the mine ends. And I put these here all together, but really they are very significant components. The mining industry, like other industries, has been fairly quick to adopt new technology. So automation, process control, GPS survey, use of drones and so on, use of blast monitoring, things like that. There's a lot of been adaptation of that within the mineral industry, certainly, and here in the province. You see a lot of fully instrumented and controlled mining equipment, milling and process equipment, and relatively active, proactive monitoring. So real-time monitoring, seeing where the pinch points are, seeing where things can be optimized. So that's in fact a fairly active component of the mining industry. It also, in terms of GPS and drones, you get accurate surveys, volume measurements, blast design, all which incrementally reduce the cost of mining and increase efficiencies and increase recoveries. All right, what about emerging a future? So that's sort of where we are now, but what's actually coming? I put the word sustainable there, sustainable mining practices, because that's sort of a buzzword. But what it means essentially is that practices are changing so that you can continue mining in a more sustainable way. So you're getting more out of what's there in the ground. You're having less of an impact on the environment, and ultimately you're able to more sustainably develop and utilize those resources. Now, these are several key areas. Increased use of renewable energy and reduced carbon emissions. Mines have always actually been using renewable energy. As indicated there, the Buckins Mine in the 1920s developed hydroelectric power generation at Deer Lake. So mines have always used, or have often used hydroelectric. But for operations that are shorter term or in remote areas, hydroelectric is really sometimes not available or suitable. So there's been a reliance on the use of diesel generators. You may have 15 or 20, probably 5 or 10 diesel gensets to operate the equipment. That, of course, is expensive now. Fuel costs are high. But also from a sustainability, it produces lots of carbon emissions. So there's an active trend towards using renewables for cogeneration of power. If the wind dies down, windmills don't work and so on. But there is active work towards and trends towards using wind, solar, and other types of renewable energy to co-generate with these diesel generators. And ultimately that reduced costs and the emissions. Another trend, which is actually active now both in Newfoundland and throughout Canada, is fleet electrification. And that's converting equipment that would normally operate by diesel to battery operation. And that parallels all the different growth that's happened with developing electric cars. So all the high energy density batteries, all the fast charging and so on, all that technology is being adapted for mining. And that has several benefits. One, of course, you're not using diesel, so you're reducing carbon emissions, but it's really important in an underground environment, because in underground mines, if you're using diesel equipment, you're producing diesel fumes, and you have to increase the ventilation requirements to clear out those diesel fumes. So if you're moving towards electric vehicles, you have a reduced ventilation requirement as well, which also, ventilation is a high consumer of energy, so it also reduces the energy consumption required for ventilation, which at the end of the day reduce costs and emissions. One thing that is emerging as well is the reuse of mining waste materials. In days gone by, the mine would close, and those waste materials, the waste rock, which probably would have been stockpiled, and the tailings, which would have been in the tailings pond, would have been left behind. And over time, there can be environmental issues with that. So the reuse of those materials does two things. One, it adds value to that material, which would normally just be waste, but also because it reduces surface storage requirements, it reduces the risk of long-term environmental consequences. And I've indicated we work closely here with Anaconda Mine. In fact, Anaconda, their operations on the Bay River Peninsula, are active in the reuse of mine tailings. About 4 years ago, they developed a dock where they actually take all their waste rock, they crush it to a specific size, and they export it. So they've exported 2 or 3 million tons of aggregate so far to construction projects down in the United States. In terms of tailings, they're actually quite active in using their tailings as a soil conditioner and fertilizer. So they're active in research to see if that material can be reused and sold for agricultural purposes. And again, it adds value to material which would ordinarily be waste, but it also reduces surface storage waste requirements for long-term environmental benefit. And finally, I just want to talk about targeting less economic deposits. You know, there's always exploration going on. There's always discovery of deposits. Not all deposits are economic. For some deposits, the size, shape, grade, complexity of the ore makes it such that if you mine it and process it, that costs more per ton than the value of the ore that's generated. So there's in fact a lot of deposits out there that are discovered, but are just not economic. So there's 2 ways to make those, just 3 fundamental ways to make those uneconomic deposits economical. You can reduce the cost, you can use lower cost mining methods, you can use lower cost processing methods, you can develop higher recovery processing methods, or some combination of all 3. And so emerging practices, research and development, some being done here at the university here, tax incentives, the government does that, subsidies and so on, are all working towards those goals. And ultimately, the sustainability about that is that you're utilizing resources that are already discovered. So you don't have to go and discover new resources. You're maximizing the ones that are already there. And not all deposits will become economic, but as this trend continues and progress is made, more and more of those existing deposits can be extracted. And in fact, that's, I want to end off with what Dr. Natter talked about, our sustainable mining by drilling technology, which we developed here in collaboration with Anaconda Mining. And just very briefly, we filed a provisional patent yesterday, so I can talk a little bit about it, but I can't discuss too much. Essentially, it's a methodology to excavate these steeply dipping deposits, not by conventional underground methods, but by drilling. So we set up a drilling plant on the surface. We drill a pilot hole strategically through the vein using downhole steering methods and downhole imaging technology. And once that pilot hole is placed through the vein, then we follow that up with a very large diameter hole opening, which follows the pilot hole and basically excavates the ore all the way from the hanging wall to the footwall. And so in that way, we're mining by drilling, and the ore is recovered at surface as the drill cuttings that are circulated surface, basically by a relatively low cost and low energy circulation system. One of the advantages of this is that it's highly selective. We're only mining within the vein. It's low cost, lower cost than conventional underground mining. Low dilution. Dilution means you take the ore, just the ore. If you have to combine the ore with host rock, which if you have a minimum mining width, you end up diluting the grade of the ore. And ultimately, because you are just traveling along surface here, and you backfill the holes with the mine tailings afterwards, it has a relatively small environmental footprint. So I want to thank you this evening for participating here. If you have any questions, let me know. In fact, I put up here the historical sources. Most of the historical information that I presented here this evening I took actually from these 2 sources. Once Upon a Mine by Wendy Martin, and All the Fire, Ore Miners in Newfoundland and Labrador by John Kitchen. And they're actually in the Memorial University Library, but you can't get them now because I have them. So I'll return them later this evening, and you guys can go get them if you want. Okay, thank you.
Thank you very much, Dr. Butt. Fascinating presentation. We do have time for questions, so I will, if you could just raise your hand, and I will come by and give you the microphone for you to ask. And we also have Jackie on the other side.
You're in the middle. You get 2 choices.
A wonderful presentation. Thank you very much.
You're welcome.
So there's a lot of innovation going on in the mining sector.
Yes.
Who's doing most of the innovating? Is it the big mining companies? Is it the equipment suppliers? Is it the universities? Is it the consultants? Where's the thinking and who's pushing innovation?
It's all four.
Anyone more than others?
Depends on the technology, depends on maturity, and depends on what the problem is. Some of the more fundamental problems like processing and imaging technology, that's where there's not a clear solution. That's probably best left for universities where we have the latitude and flexibility to do that type of work. But a lot of the companies themselves have, if not research divisions, they have collaborations perhaps with universities and research centers and so on. So it depends on the level of the innovation. If it's something that's tweaking and modifying existing technology, optimizing, that may be company driven. If it's something that's more fundamental, it may shift more towards universities. And there's a lot of incentives actually right now. The government of Canada, through tax incentives and subsidies, is actually driving a lot of this research and development towards sustainability. So all these things about reducing carbon emissions, reducing footprint, there is an economic benefit for doing that through these subsidies and tax incentives. And $1 million prizes if you're lucky. So.
A couple of things you didn't mention. You didn't mention robotics at all in looking to the future.
I talked about automation.
Okay.
That sort of includes robotics. So
Yeah.
if you have a machine that operates on its own, that's really automated. Yes, you're right. There's potential there for that as well.
Are we seeing any use of robotics in the province?
A lot of mining equipment is become really automated. So the operator can set up, say, a drill jumbo. They can set it up at the correct location and push a button, and everything after that is done is automated. And we've worked again with Anaconda and some other companies developing systems that monitor the parameters while you're drilling, so anti-jamming systems, so to make sure that hole can be drilled cleanly and efficiently. So there's a lot of built-in automation. It's not fully robotics, but a lot of things have been automated that way, which makes errors be reduced and makes it able to be operated by fewer people. So,
And looking way out there, how soon do you think we'll be mining asteroids?
Asteroids, I have no idea. Not next year. Not next year. Unless one falls to Earth, then we can mine it pretty easily. But again, I talked about. I just made a joke there, and you did as well. But targeting less economic deposits. Before we have to go to the stars, we should look at what we have here first. And so we have a lot more resources here, particularly with regard to precious metals and gold, because there's a lot of these small veins out there. And to make a commercial mine, you've got to have 5 or 10 of these together. So there's a lot of places where there's resources that are uneconomic. And rather than build spaceships to go to asteroids, we should work, I think, on maximizing what we have here first. And being able to exploit the resources that we already have.
I read many years ago Wendy Martin's, right here.
Oh, yes, sir.
Wendy Martin's book, and I was astounded at the time by the number of mines that existed in Newfoundland in our history. Most of them discovered 100+ years ago, and obviously exploration methods were very primitive. There was limited capital available for exploration. And today we have such sophisticated methods for exploration, so many advancements in technology. Why, and perhaps you'd be a rich man if you could answer this really, why have we not discovered further mines? Why are there not many more mines operating in Newfoundland on the island? Copper mines and iron ore mines like Belle Isle today. with them. Perhaps there's not enough exploration being done, but I'm astounded that there's not more mining being done in Newfoundland right now.
I would be rich if I could answer that very clearly. I think you're right. There are advanced exploration methods, but they're not perfect. There's room, in fact, to improve those as well. And in fact, the last year's winner of the Disrupt Mining was also a Newfoundland-based company, Acoustic Zoom, based in Paradise. So this is the second year. It's only been going for 3 years, and for 2 years in a row we have companies and organizations here from Newfoundland participating. But they're working on improving the ability to image ore bodies. Some types of ore bodies don't image very well, so there is certainly room for improvement there. Why haven't we found it all yet? Maybe cost versus technology. I don't know.
By no means am I an expert in this field, but I would just follow up and concur with what you said at the end there, Steve. It's about cost. So even though there were many mines in the past, in those days, operating costs, were lower. So relatively speaking, the economics, I suppose, were there. Whereas times are different, operating costs more. So that's actually what engineering is a lot about. The technology is there. They can be developed. There are resources, but it has to be done in an economic way. So that's just following up on your point, Steve.
That's a very good point because, in fact, mechanization has made mining very, very, very rapid. You can mine now at rates much, much higher. Most of these older deposits, had 50-year mine life, could be developed now probably in 15 or 20 years because of the rates of mining and the levels of mechanization. But what that's also done is it's increased the threshold for economic viability. So we're mining faster, but now the deposits have to be this much richer to be economic. So there's also a reason to go back now and look at these more selective, perhaps slower, but more selective methods. Existing methods or developing new methods like we proposed here that can make these currently uneconomic deposits more economic. So there might be a lot more mines yet.
I agree with you. And some major mining companies, which is where the capital is, that need the elephant-sized deposits to be able to reach their threshold.
Mm-hmm.
You think that the entrepreneurial spirit and the risk-taking that the people in the past exhibited, you think that's present in today's world? And also, you didn't mention rare earths, and I guess I'm starting to hear a little bit about rare earths, especially in Labrador. Will these new techniques probably favor the development of rare earths, you think, in the province?
Yeah, in fact, at one point I did have a slide about that. I talk about deposits here, igneous metamorphic, fluorspar, rare earth elements, electronic tritium and diamonds. So again, that does relate to demand. And rare earth elements are these very, very rare trace elements, show up usually in granite plutons, things like that. Like, I forget the names, neodymium, and they have all rhodium and all kinds of names like that. But they're important for electronics. So that is, in fact, an emerging market because the demand is there that wasn't there before. And there are, you're right, there are rare earth deposits that have been delineated. And I mentioned earlier in the presentation there's 4 active development projects. One of them is, in fact, for rare earth elements in Labrador. I didn't mention this because I didn't have enough time.
The entrepreneurial aspect perhaps existed, and the entrepreneurial aspect that probably maybe existed more yesteryear than today. Do you think that's true or not?
I think entrepreneurial, I think you can combine entrepreneurial with innovative perhaps, because both involve risk perhaps. So by being innovative, you're also being entrepreneurial, by taking that risk and potentially making something that's, discovering something that couldn't be discovered before, or making something that's been discovered more economic. We have a center here, I can plug the Union faculty again, for entrepreneurial, the Center for Entrepreneurship here at Memorial, and I think they may have some activities in that area as
Just to follow up on Jeff's question, Steve, on this point, are there any uranium resources in Newfoundland and Labrador?
Very big uranium resources. There was, in fact, a very, very large uranium deposit delineated in the 1960s. The Michelin deposit near Postville, just south of Nain. On that number, it would be, I might be a little off. It's around there. And in 2007, a company, I forget the name now, Altius Resources maybe, they had were about to bring a very large uranium deposit into production, but it's right on the border with Nunatsiavut, and in 2008, the Nunatsiavut government put in a uranium mining ban, so it got stopped by politics. But it's a very, very large deposit, and it was a very opportune time because at the end of the Cold War, when all the nuclear powers were getting rid of their nuclear warheads, they were putting plutonium into the uranium market. So the price of uranium went way down. And around 2005, 2006, that plutonium was being depleted, and then the price of uranium was coming back up. So it was forecasted to go up almost tenfold, or something like that. It was a very good time to start that mine. But unfortunately, the uranium moratorium was put in place. I think recently the government of Nunatsiavut has renewed that uranium moratorium.
Thanks. First, thanks for your presentation. But my question is that do for most of these explorated mounds had been applied or evaluation deposit for economic analysis or not?
Sorry, could you just repeat the last part again?
Had been applied or evaluation deposits for these explorated mounds or not?
Have they all been explored, you mean?
For evaluation or deposits, had been applied for all of these explorated mounds or not?
Depends on the size. Some are too small, it's obvious they're uneconomic. When you have something that could be potential, you do a more detailed feasibility study. You basically plan out a mining operation, you cost it out, and you look at the economic factors to indicate if that's going to be profitable or not. So some of these deposits turn out to be, absolutely go ahead. Some turn out to be not economic, and some turn out to be marginal. And it's those marginal deposits where some change in commodity price, like uranium, tenfold increase in price can make that a good. Gold, it wasn't that long ago, the gold was worth only about $100 US. Now it's $1,500 US or something along those lines. So changes in commodity prices can make these marginal deposits more economic. Or on the other side, changes in technology, the cost of mining, the cost of processing, or the recovery that you get from processing. Changing one of those can also make these marginal deposits appropriate to be mined, to make them feasible.
Thank you.
Yeah. And to keep people honest, all these feasibility reports end up being filed with the Department of Natural Resources, so you can go back. Companies can't keep all this information secret, so you can go back over these past studies and do your own investigation, and without having to actually put anything into the ground, you can benefit from all the other work that past companies and organizations and individuals have done. There's a mineral resources database, I think it's called Geo something. It's the Department of Natural Resources website. You can get reports that go back through a long period of time.
Hi, is there any interest in, or do you foresee any activity around offshore mining?
Yes, in fact, again, our method, sustainable mining by drilling, can work from a floating barge as well, because you're basically drilling into the ground. So just like you can drill offshore from a floating platform or a fixed platform depending on the water depth, you can also apply this method for offshore. And it would probably be nearshore. There's two types of offshore, right? You're looking at placer deposits where you basically have gravels that have been transported by the rivers, and you can excavate those fairly easily. Those can be mined, by dredges and things like that. But this could be used to do bedrock mining offshore, where you're actually excavating into the bedrock and not just taking the sediments that are on top of the bedrock. So there's the potential there for that as well.
Okay, well, I think that concludes the questions that I can see here. Well, Steve, I can say that it's been a fascinating presentation again, as I mentioned, and with the rich history of mining that I was not really fully aware of in the province. And I think a lot of us have learned quite a bit from this presentation. So on behalf of the Faculty of Engineering and Applied Science, Steve, I'd like to thank you very much, and a small gift of our token of our appreciation this evening.
Oh,
so
thank you very much.
Thanks a lot, Steve.
Thank you very much. Thank you. Thanks, Greg. Thank you. What did I get?
Also like to
Thank you
give a
very much.
call out to Jackie Locke, who did a wonderful job in organizing this event and doing the work behind the scenes on this in all of our lectures. So thanks, Jackie. At this point, I'd like to also welcome up Jeff Emberley to say a few words on behalf of Paganel.
Thank you, Dr. Natter. Just a few words about Paganel. As Greg said, we have a particular role to play in the province, but and I'll go into that somewhat. I recognize that there are a fair number of engineers and some geoscientists here tonight, but still I think it's worthwhile just mentioning a few things. Paganel, of course, is professional engineers and geoscientists, Newfoundland and Labrador, and we're organized under a provincial act. We're actually a regulating body. Some people don't think of us that way, but we actually license engineers and geoscientists both. Initially, we were engineers when we were formed in 1952, and later on, when the geoscience community felt that it was appropriate to be regulated and government agreed with them, they amalgamated geoscience with engineering as a regulatory body, and that became Paganel as we know it now. But essentially, we're organized under a government act. We basically administer an act. Our board of directors are partially from the profession, but also appointed by government ministers and who are not engineers, geoscientists. So that's a very important part of us administering the practice in the public interest. That's the requirement of our board. Paganel's Code of Ethics, for example, requires its license holders to uphold ethical standards. We have a code of ethics and a disciplinary process, so that if somebody gets out of line, we can bring them in line, and that's part of our role. We're also concerned that people have greater awareness about engineering and geoscience issues, and that's an important part of what we see here today. We feel that a better informed membership, but also a better informed public can think about these things in a better way, and maybe government can think about them in a better way too. In terms of Dr. Butt's presentation today, it's like Dr. Natter said, I had an awareness of the degree that this contributed to our economy and our lifestyle, but certainly it's been an important part of our lifestyle for far longer than I thought, and that's a thing that we want to continue into the future. And I guess, as we all know, the province needs as many resources and opportunities to develop that we can, and this will be an important part of our future, I'm sure, and hopefully it will be a bigger part of our future. So thank you very much, Dr. Butt, and also please enjoy, outside we have some wine and cheese, so please hang around and have some discussion, and thank you very much for coming.